All right, we're starting out chapter 8 with section 8.1a, geometric mean, and really what we're going to be talking about today is simplifying, if I can spell, simplifying radicals. And that's the first step to do geometric mean, which we'll talk about another day. All right, so we're going to talk about product property here. And this goes back to, well, before you took algebra. The square root of two numbers together, so a times b, equals the square root of them separately, right? So if we take the square root of 2 times 3, we can separate it to square root of 2 times square root of 3, like so. So we're going to use that property today as we simplify radicals. We're going to do backwards and forwards in that, and that's pretty much what we're going to be doing. All right, simplify square root of 50. Okay, there's a couple ways to do this. First of all, we have to know our perfect squares. Okay, so I can start to list them out here. You can Google these, you can look them up. But if I start with 1 times 1, I get 1. 2 times 2, 4. 3 times 3, 9. And so on. I'm going to write them out here. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. So those are my perfect squares. So 2 times 2, 3 times 3. Now, a couple different ways to do this. Anytime I see a number, and it's an even number in this case, I can pull out an even factor and solve. So my first factor I'm going to pull out is a 2. Okay? Then I'm going to say to myself, what's 50 divided by 2? Since it's an even number, I can cut it in half. And that number is 25. I look over at my perfect squares, and I see 25 there. So now what I can rewrite this as the square root of 2 times the square root of 25. And when I think about the square root of 2, it does not, I can't reduce it any farther. The square root of 25 is 5. And so I can rewrite it like that. My final answer really should be written as 5 times root 2. Okay, another example to look at 50 is to say, what's the largest square root factor that goes into 50? It can never be greater than 1/2 of 50. So I look at 25. If you look at any of those other numbers, they don't go into 50. The next one will be a better example of that. All right, I'll list my perfect squares out here again so you can see them. And actually, I don't have to go any higher than half of 48. So if I go up to 25, 25 is more than half of 48, so I don't have to do that. All right, I'm going to start with the first method. It's an even number, so we'll pull out a 2. 48 divided by 2 is 24. Okay, so here's my problem now. I therefore have another even number. So now I have to do 2 times 12. And then I have another even number, 2 times 6. I have another even number, 2 times 3. Okay? So what I can look at here is I have all of these 2's out here. I have 2 times 2 times 2 times 2. Let me circle these in a different color. So I have 2 times 2 is 4. I'm going to put an x in between because I'm going to multiply all those together. 2 times 2 times 2 times 2 equals 16. So I can write root 16 times my only other number I have left is 3. And when I take the square root of 16, I get 4 times root 3 is my answer. Now, another way I can look at this is I can say, what's the greatest square root factor that goes into 48? I can do 48 divided by 3, 48 divided by 3, and I get 16. Or 48 divided by 16, and I get 3. So then I know, okay, root 16 times root 3, square root of 16 is 4, root 3. So 2 different ways to find the square root of 48. Okay, we're not going to talk about geometric mean right now. Find the geometric mean between 4 and 45. Okay, what the geometric mean, what we're going to be doing, it means take the square root of those two numbers multiplied together. Before I multiply that into a big number, which you are more than welcome to do, I'm going to take these two numbers and separate them. So I'm going to take it into the square root of 4 times the square root of 45. We know the square root of 4 is 2. What is the square root of 45? Well, here's my factors again. I'm going to go up until I get less than half of 45. So what I would do is I would say, what's 45 divided by 16? It doesn't work. What's 45 divided by 9? And it is 5. So I have root 9 times root 5. And now I do 2 times 3, because that's the square root of 9. And my answer is 6 root 5. Okay, another way to do this is to multiply these together, and I'm going to get root 180. And I have to say to myself, what's the highest factor? And I have to go all the way till I get less than half of 180 of my perfect squares. What you're going to do is if you are unsure of what goes into 180, you take your calculator, do 180 divided by 81, comes out as a decimal. 64 comes out as a decimal. 49. 180 divided by 36 is 5. So I'm going to have those two numbers, and then I reduce it, and I get 6.5. Okay? We'll try these two problems. We're going to do root 12 times root 15. What we're going to find is that 15 breaks into 3 and 5. It cannot be reduced. So I'm going to reduce 12. My greatest factor in 12 is 4. Okay, so here's where it gets a little tricky. Now I do 2 times root 45. But we know that root 45 breaks into root 9, root 5. So I get 2 times 3 times root 5. 6 root 5, or 12 times 15, we're going to find out is 180, and we're going to do the same thing that we just did up there. All right, so 6 root 5. Let's do between 2 and 50. I'm going to erase this. Let's do between 2 and 50. Root 2 times root 50. Well, if you guys look at this, you'll know that they equal 100. Square root of 100 is 10. So the geometric mean between 2 and 50 is 10. So in review, geometric mean is we multiply two numbers together and we find their square root.